In this section, we will take a look at differentiation of exponential functions. Now, exponential functions are such, right? This is nothing new to you. If I differentiate ax, I'll get ax ln a. What is more familiar to all of us is if a is actually e, that means if this is e, right? Most of us will know that differentiate ex, you get back ex. But generally, I think this is a more generic form, because if you think about it, if a is actually e, then when you differentiate ex, I'll get ex ln e, and ln e of course is 1, so therefore I get this. So this is the proof of this, correct? So another example, if I say, okay, if a is say 5, so differentiate 5x, I'll get 5x ln 5. Alright, so that's how you apply these two. Now there is of course a chain rule version. Chain rule version means it is a to the power of fx. Instead of x is plural of fx, the chain rule version says that you have to differentiate the inside, which is to differentiate fx, you get f prime x. The equivalent chain rule version of ex, of course, is this. Now, if you ask me, the master formula is the top left-hand corner here. Yes, if you can remember this one, then this one is obvious because when a is e, the chain rule one is also quite obvious. You can get this and this. Okay. A few notes before we carry on with some examples is this. First idea, which is this. All right. How do you prove that ln e ln fx is actually fx? Now that's the proof. Right. Let ln this one equals to k. Now, if I can somehow show that k is fx, my job is done. Correct? I repeat one more time. If I can show that somehow k is fx, okay, if I can somehow get from here to here, my job is done. Not difficult. I take ln on both sides. Yes, I use power law to bring it down. Ln fx ln e equals to ln k. Now what is ln e? Ln e is just 1. So therefore ln fx is ln k. And if ln fx is ln k, then therefore k is fx. If k is fx, then this one is actually just fx. Now the second result is a consequence of the first. What do I mean? Right. If you see here and here, if you can get from here to here, it's quite obvious, correct? Because e ln ax is just ax, right? So if ax therefore is e ln ax, and therefore is ex ln a. Why? Because you use power law to bring the x down. Now, why is this useful? In some examples, we will take a look. But for now, you accept these two as a result that you will use. Okay, thank you.